Okay, so given the current situation where we have so many persons working from home or working remotely, not traveling to work, we discussed this in the last class, and the term used for this which is working from home, not having to travel, is what? What is the term we use to define this? Anyone remember?
Yeah. Sure.
Yes. What's that, Miguel?
I say you could repeat the question.
Yeah, the term used to describe working from home or working in a location, any location instead of the office, is what? Anybody remembers? Okay, well, the term used is telecommuting. Remember we discussed that in the last class.
Yes, sir.
Right, yeah, telecommuting, right? So this is something a lot more persons doing globally, right, over the next couple of weeks. So they'll be telecommuting, working from home, doing things, their jobs online as opposed to in the workplace. Now, with telecommuting, were there
Wait, Mike. On his screen? Because like I'm not seeing anything.
Yeah, guys.
Yeah, not on the screen.
Yeah, the screen isn't active just yet. What I want to do is, in working from home, what are some advantages or disadvantages, if you could tell me?
You're in the comfort of your house. Some disadvantages could be like your neighbors are making noise or something. Or that it's like it's
So you
One
got one
disadvantage you might not have all the tools that you have on work.
Right, correct. So yes, so one advantage is you're at your home, you don't have to actually travel or spend time traveling. Disadvantage,
so you might have flexible working hours.
Correct, you could have flexible working hours. That's right. Another disadvantage for the person is, they now have to pay the bills, the utility bills, etc. One advantage to the employer is the same concept, is they now have to pay less utility bills, right? All right, so that was just some little revision there for what we did last week. Now to get into the topic, what I want to start on today, previously we did the programming as part of the SBA, right? And today I want to go through some theory as it relates to programming, and we're going to go through that today with some examples. So let me share my screen. 1 second. Okay, let me see. Sure. Hold on. All right, you'll see my screen?
Yes, sir.
Yeah, okay, good. So we're going to begin speaking about this program implementation. So now in previous classes, we introduced the concept of problem solving and writing algorithms, pseudocodes. We also did flowcharts as a form of detailing the plan on how the program will be written. Now, it is during implementation phase that the algorithm must be converted into actual programming, right? Or the source code is what we call it. So before the implementation, we would be putting the plan together, putting it in a language where we can read at a high level. Now, the implementation phase, there are about 4 steps. The first step will be to translate the algorithm into a programming language, right? And the language most persons used are one of the languages is Pascal. The second step will be to locate and correct any errors in the code, such as syntax errors. And a syntax error is an error resulting from incorrect use of programming language syntax. An example of that will be using write line, WRITELINE, instead of write LN. Okay, so that's one example of a syntax error. Logic error is an error made by the programmer. So that's, for example, using an incorrect arithmetic operator. So if it is you wanted to multiply or find the product, which is multiplication of 2 numbers, you use a division, etc. After correcting those errors, the next step will be to execute the program code, right? Compiling it, executing it. And then after that is running as it should, you will look to maintain the program, which would include program documentation. Right? Any questions on that?
No, sir.
Everybody okay? All right. Now, choosing a programming language. As you know, you have the option, or they are the option of using many languages, right? The one used was Pascal. Does anyone have or know of any other programming languages? So there are many others, right? So there's like Java, there's Python, there's C, C++, etc. So there are many programming languages that can be used to create or to code your programming. Now, programming is the art of writing the solution to a problem using a language that the computer can interpret. Because at the end of it, remember, when you do programming, you're telling a computer or giving a computer instructions. So the computer needs to interpret these instructions. A programmer actually instructs the computer how to solve a problem, since it cannot come up with a solution to the problem itself. Right? So the computers, they generally don't think, for the purposes of this discussion, they don't think for themselves. We have to tell the computers how to operate, basically, how to solve the problem. Now, a computer program, by definition, is a set of instructions that tells the computer what to do and how to do it. These instructions are usually converted into a sequence of numeric codes called machine code and stored in memory. So what happens is the programming language, before the computer understands it, it is converted into machine code, right? And then that is stored in memory. And a type of memory, or another word used to describe memory on a computer, is what?
RAM.
RAM. And RAM means?
Random access.
Good, yes. RAM, random access memory. Good. And is RAM volatile or non-volatile?
Not volatile.
Volatile means easily erasable. So RAM is volatile memory. Okay, so that's a bit of revision there. Now back to the programming. The programming language is selected depending on the task. So what is the outcome? What it is you need, the objective, what you need to meet or fulfill. As I mentioned before, there are many programming languages that can be used to write programs or create other kinds of software. Generally, we could group languages into two categories, two types: low-level languages and high-level languages. When discussing or when speaking about low-level languages, these are languages that are only understood by a computer or a processor, which is a device inside a computer that is used to write the code. Now, machine languages uses the digits 0 and 1 to make a binary code, and that is translated to the instruction that the computer or processor will use. An advantage of a low-level language is that the code runs quickly and efficiently because it's directly executed by the CPU. And CPU stands for what? The acronym stands for what?
Central processing
Central
unit.
processing unit.
Central processing unit. And the CPU consists of two major components. And what are the two components?
The ALU and the control unit.
Good, the ALU and the control unit. Right. So the code itself, an advantage of machine languages, that code is run directly by the CPU. Now, a disadvantage is that because the code is at such a low level, ones and zeros, it's difficult to interpret that. As humans, we're not familiar with this way of communicating, right? So it's more machine dependent, low-level languages. Another type of low-level language is called assembly language, right? And that has the same structure and commands as machine language by allowing programmers to use abbreviated words called mnemonics instead of binary. So instead of writing the code as a string of binary bits, generally meaning add contents of A to contents B, right? You could use some sort of English and letters to carry that message to the computer. Now, advantage of assembly language is that it could be easily converted to machine code by a program called an assembler, right? So assembler would convert the assembly language to machine code. Disadvantage to a certain extent, it is still more difficult to understand compared to high-level languages, right? So it's also machine dependent. So that's some examples there of low-level languages. Now, the other category we discussed are high-level languages, and it is different when compared to low-level languages in the sense that it's not machine dependent, right? Okay, no, right. So therefore, programs written on one computer can be run on another similar computer. Now, they also use keywords similar to English and are easier to write. As you would notice when you did the programming in Pascal, they use some English words that was easy to understand. Okay. Right. Now, the high-level languages are converted to machine code rather like translating from one language to another, so that the computer can carry out the instructions on the CPU. So at the end of it, there still needs for the language to be converted to machine code in order for the computer to understand. So that process needs to happen regardless. Now, advantages of high-level languages would include the use of English type words, making it easier to understand and create and interpret. Disadvantage will be for the computer is that the programs have to be converted to a machine language, right? So as mentioned before, Pascal is an example of a high-level language, and then there's Visual Basic for Applications, or VBA. That's another example of it. Okay. All right, so let's see next. Okay, so the other thing to discuss would be syntax and semantics. Now, different programming languages generally have different syntax and semantics, right? That's what makes them unique in terms of coding compared to another. Now, syntax is the precise way in which the statements in a program must be written in order to be understood. So there are rules, keywords that are required. Anybody remember some keywords that are specific to Pascal when you did your project?
Wait, is prompt one?
What's that, sorry?
Prompt?
Font?
Right line.
Prompt?
Yeah, prompt.
Prompt, it had write line, yes, read line, correct? So remember, those words, for example, you couldn't use it as like a variable, right? You could, those had specific meaning to the
The counter.
Count was a variable. So
Okay.
it wasn't specific. That could have been, count could have been of type integer if you wanted to have a numeric count. It actually could have been a type string if you wanted to store some letters or characters in it, right? So, so that's syntax, right? The syntax allows the programmer to create a correctly structured statement that is legal, right? Now, meaning that it is a statement as allowed, but note that if you're using the correct syntax, it doesn't guarantee that the statement will actually produce a result that you're expecting. And what that means if you want to find the average of marks or grades, and you say divide the total divided by the number of students in the class, that is the formula to calculate the average. But if you, instead of dividing, you multiply or find the product, that is illegal, or that statement will be allowed in a program, but it will not give you the result that you're looking for. Okay, so it's two different things. One is that the syntax is correct, and two is that it will give you the result in which you need. So that's syntax, right? The other point is semantics, and semantics means associated words, phrases, and punctuations that make up the language. So you will remember in Pascal, at the end of every statement, every operation, for the most part of it, a semicolon was used. And that was to let the program know that that's the end of that operation, that action. Now, some languages, they may not use semicolon, they may use another character. And there are some languages that doesn't use any character at all for that, right? So there's a difference in itself between different programming languages. Any questions on this so far? Yes.
For CX, right? We gonna have to write out a program.
Using a programming language itself, no. You will not have to write any program, but you could be asked questions about it. So for example, you may be asked, what's the difference between a high level and a low level language, right? Or what's the difference between semantics or syntax? Or it could be that you're given a scenario and ask a question of programming generally. So there'll be no program-specific question. And the main reason for that is with the new syllabus, there is no program-specific requirement for the students. They could choose any programming language they want to use. Okay?
Yes, sir.
All right, good. Any other questions? No? All right.
No.
Okay. So the next thing I want to get into is the program structure, the structure of the program. Now, almost all structured programs have a similar overall structure, right? There are statements to establish the start of the program, right? And you remember the start of the program in Pascal, it started with what word, what keyword? Remember begin?
So you talking to me?
Yeah, well, I was talking to the class. Remember, begin was the keyword used to structure the program,
Yeah.
right? So that's that. So all programs generally have that structure. All right. The declaration of variables, right? There was a section dedicated to that. If you all remember, at the beginning of the program, you would use the keyword var and then type the variable names and what type of variable there was, right? So that was the case there, right? Then there is program statements or blocks of code that would include while loops, for loops, this sorts of things. So you have to write that in a block of code. Right? So those will be the same when it comes to multiple programming languages. So they all have the same sort of concept, but it is the rules are usually specific for each program. Okay, the next thing we want to get into is running a program. So I'm just going to okay, so running a program. So after you have the program typed in an editor, right? That's usually called the source code. So you type the program in some sort of editor, text editor, and that output there is referred to as the source code. Next, it needs to be tested for correctness. So you should always test your program to ensure it works as you planned. To do so, the source code must be translated into a machine language called the object code. So there are two key things there, right? There's source code, and that is used to describe when the programmer, the user, types the program in an editor. And then there's object code, which is the term used for when the source code is translated into machine language. And the object code now is what the CPU uses to carry out the program instructions, right? Now, in converting a program from source code to object code, it is done by something called a translator or a translator program. There's another thing, an interpreter translates the source program line by line. And if an error is detected, then the translation is aborted, meaning it stops. Right? If no errors are detected, then the interpreter instructs the control unit to execute the translated instructions. Right? So that's important to note. It will be executed or translated by line by line. Okay. The cycle will be repeated for every instruction in the program. So that's one way of converting the source code to the object code. Now, a compiler translates all program instructions at one time and produces a standalone object. So a compiler is different from an interpreter. Okay, the interpreter would translate the source code line by line, and the compiler will translate all instructions at one time and produces what is called a standalone object program that can be executed or run on its own. Error checks for syntax and logic errors are performed, and an error summary is used. So given the definition or the type of operation between interpreter and a compiler, what it is we used or what you used when you did your programming for your SVA? A compiler or instructor? Interpreter.
So I think it was a compile because Mr. Ravi helped us with it.
Okay, but what, based on how we defined it, what sort of behavior did it have to make you say it's a compiler? If you remember, when you compile the program or run the program, it would show success and execute the program if there were no errors. And if there were errors, it provided a list of errors in the messages window. Anyone remembers that?
Yes, it goes show up green or yellow.
Exactly right. So the green would have mean it was successful in terms of what you all had, and the yellow was when there were errors, right? And then you had to address the errors by itself. Now, once the program is compiled and no errors detected, the compiler will then instruct the control unit to start executing the program. So that means the program doesn't have any sort of errors, and it could be run. Now, if the program produces incorrect output or stops unexpectedly, then another type of error may be the cause. Okay, so that means it compiles properly, but for some reason the program doesn't work as it should. So in our case of the SVA, your program may compile, but for some reason the totals were not adding up. When it is you enter the guest name and the base cost, it wasn't correctly classified in all these sorts of things. So that's another error that could have happened. If that works well, then the object program will be executed each time it's run. And that's the object program. The source code only needs to be compiled once. So there's no reason for any action after that again. If there are any modifications to the source code, then it must be recompiled, and you all saw that. So if you compile the program and then if you compile the program and there were errors and you did something to fix the error, you had to recompile the program again. Right? Everybody remembers that or experienced that?
Yeah. Yes,
Okay.
sir.
Yes, sir.
All right, next thing I want to get into is programming errors and errors that could occur while programming.